Time travel is a thrilling idea found in countless stories. Imagine reading a science fiction story where a kid steps into a shiny machine, pulls a lever, and boom, appears in ancient Egypt, chatting with pharaohs. It's exciting, magical, and so impossible. Let's dive into one classic time travel puzzle called the grandfather paradox. Picture this. You hop back in time and accidentally stop your grandfather from ever meeting your grandmother. That means your parent wouldn't be born, and neither would you. If you were never born, how could you go back in time? The grandfather paradox is super confusing because it breaks our usual idea of cause and effect. Usually actions happen first and then create results. But if you can change events that led to your own existence, the world gets tangled up. Time travel isn't just cool, it's downright strange. If it were possible, we could rewrite history, fix mistakes, or make new ones. We could meet ourselves or create loops where events have no real beginning. Time would feel less like a straight path and more like a knotted string. The great physicist Albert Einstein showed that time isn't separate from space. They're woven together into space-time. Imagine space and time as a flexible sheet. Gravity and speed can stretch or shrink it, changing how time passes. Einstein's theory of relativity tells us that if you move really fast, close to the speed of light, time slows down for you compared to someone standing still. Astronauts experience a tiny bit of this, but that's just dipping a toe into the future. It's not jumping back and forth like in sci-fi. Does Einstein's theory open a door to actual time travel? Scientists have found that while it allows for slower or faster ticking of time, it doesn't easily allow you to flip the direction from forward to backward. It's like having a stretchy clock, but not a reverse button. Some wild theories suggest that special tunnels, called wormholes, could connect distant places and maybe different times. Wormholes are like shortcuts through the universe's fabric. In theory, if you zip through a wormhole, you might pop out in a different era. But this is pure speculation. No one's ever seen a wormhole. Another idea involves closed time-like curves, fancy words for loops in space-time. If such loops existed, you could travel around them and return to your past. But scientists doubt these loops can form naturally. They might need exotic matter with strange negative energy, a substance we've never observed. What about quantum physics? The tiny world of particles is weird, with particles popping in and out of existence. Some hope quantum mechanics might solve or allow time travel. But so far, quantum theory hasn't given us a clear path to building a time machine in your garage. Scientists also think about multiple timelines. Maybe changing the past spawns a new, separate universe. This could avoid paradoxes. Your grandfather is fine in one timeline, but in another, you never existed. It sounds neat, but we have no evidence multiverses exist. So, from Einstein's ideas to wormholes to quantum tricks, we have concepts that tease us with time travel possibilities. But every time we get excited, we hit a brick wall. Either we lack the technology, the energy, the materials, or we run into nasty paradoxes and no evidence it's possible. Part of the issue is we don't fully understand gravity, quantum physics, and space-time. Without a theory of everything that unites these concepts, time travel theories remain guesses, not tested facts. We need breakthroughs that might still be decades or centuries away. It's important to understand that time travel fascinates us because it questions our everyday logic. It makes us think about what makes now different from then. Could history be a place you can visit? Or is it gone forever, locked behind us? For young explorers like you, thinking about time travel is a great way to learn about physics. It pushes us to understand Einstein's relativity, the nature of light speed, and the structure of our universe. Even if we never build a time machine, we learn a lot on the journey. Time travel also teaches us about consequences. If you could change the past, what would it mean for your present life? Would you fix mistakes or cause new troubles? Thinking about these questions helps us understand that our actions now shape the future we will live in. Still, never say never. Science evolves, and what's impossible today might be possible tomorrow. Keep questioning, keep learning, and who knows what secrets future scientists will uncover.